Let us look at a case of quenching heat treatment where it was necessary to understand why a certain variation of hardness along the periphery of steel rods, typically of 90 mm diameter, was observed. The hardness was found to vary from 43 to 48 HRC. The planned practice was to stack the rods horizontally in containers, preheat them in the furnace, and lower them into an open quench tank. A non-uniform soaking at the time of withdrawal from the furnace and flow of the quenchant around the periphery of the rod were anticipated because of stacking. A test rig was designed to collect the time temperature data during heating and quenching. 4 thermocouples were inserted 90 degrees apart, 5 mm below the surface along the periphery of the rod. The data was used as input to InverseSOLVER and the results showed the maximum surface cooling rates varied widely from 73 degrees centigrade per second at the top to 320 degrees centigrade per second on the left side, with the maximum heat flux showing similar variations. There was also an asymmetrical heat flux distribution which showed the influence of neighboring rods affecting the flow rate of the quenchant. This procedure can be usefully employed to design optimum stacking sequence for immersion quenching in containers. InverseSOLVER can be used in all cases where process is inaccessible for direct measurement, for the estimation of metal mold heat transfer for casting simulation, efficient design of water or spray cooling systems, selection of mold coat material and thickness in die casting for increased die life, measurement of contact conductance across metallic or non-metallic contacts, measurement of heat flux in all types of welding, friction welding, etc. for quality control, modeling heat transfer coefficient in boiling, condensation, radiation, forced convection, in space technology for design of heat shields and the like, in nuclear technology for design of complex cooling systems. InverseSOLVER coupled with the newly designed tool reference quench probe can be used for in situ determination of cooling characteristics of quenchants of all types.